Well, hello friends. Today we are going to set a little trap for the root user on Serenity because I realized something when I was mucking around that this is the path that we have by default in the shell. But even if that is our path, if I copy some binary to the current directory and run it like this, it still works. So even though it's not part of the path, we're still looking in the current directory when running a command. And this is not good because on other systems you have to do /foo or like non-foo to get that binary. But here, just a simple foo. So there are various ways that we can take advantage of this situation, right? So I figured instead of just me fixing the bug, why don't I make a video of messing with the bug before fixing it? Might be a little more fun that way. So I figured that if you have a directory like /temp, right, you could imagine that for some reason the root user would come to /temp and run ls for whatever reason. He just wants to see what's there, right? And we could totally take advantage of that by making a substitute ls, putting that in /temp, having it do something sneaky, maybe like hook ourselves up with a root shell, and then just wait for root to run the program, basically. Now, of course, since we control this whole system here, there's no root user who we can just sit around and wait for to run the program, so we're going to have to do that part ourselves, but it'll just be a fun little exercise regardless. So let's just make ourselves a little evil ls program, and this will be the thing that we put in /temp. So I imagine that we want to forward execution to the real ls after we finish doing our sneaky thing, just to make sure that the root user doesn't get tipped off by ls behaving strangely. So I guess what we want to do then is something like exec l bin ls arch v or wait, which one is it that we do? Is that the one that we want? Exec v? I think that could work. Okay. And then here we want to do something sneaky. So what's that going to be? I guess we can just check that it works first, because I'm not completely confident about the exec thing here, if that's a fine way of doing it. I think it is, but yeah, evils. So we can put bin evils in temp, and then say that root comes along and he's like, la la la, I'm root, right? And then he just, well, if we imagine that we had named the file correctly, let's do that. Okay, so now we ran the file here when doing ls-l, and of course when root is here, he will run that file as well. So, okay, that works nicely, and the arguments gets passed along and everything. So I guess what we want to do is maybe install this file somewhere else and have it behave differently there. We can do something like if KUID 0. We could do a what's the laziest way of doing this? Let's do system. Then copy temp plus bin sneak. All right, and then we can chmod it as well. Where's chmod from anyway? From for control or stat. Bin sneak, and we'll set it to, is that the one? I think, I always forget if it's like that or like that. No, it's like this. Okay, this is the set UID, and then of course it needs to be, oops, we need to make sure that the file is owned by root. And I guess we should also do MV, or we can do CP, that's fine. Okay. And then we can listen for some secret argument. If argc is 2 and argv1, stir comp, all right. X is for hacks, like that. Then we will set UID 0, set gid 0, and exec l bin sh. Like that. And what am I missing? For strcomp, we need string. There we go. Okay, so if this program is run as root, it will copy itself to bin sneak, make it owned by root, and set UID root. And then if you run this program with -x, then it will give you a root shell. So maybe this option should be even sneakier. Hacks. Nobody will expect that to work as an ls argument, right? Very sophisticated hacks going on here. Okay, so am I doing this right, I wonder? We'll see. So we'll just put this thing in temp ls, and then we will, I guess we can go to temp, run ls. Of course, things work as normal. Like a really sneaky, sophisticated version of this, I suppose, would even hide this file. But we don't have to get that fancy. But if I go to temp, ls, then is there now a sneak -- hacks that I can do? Yes, there is. And it gives me a root shell. That's pretty sneaky, right? So all that it took was us putting a replacement ls binary in /temp and just waiting for root to go there and run it. Now, of course, this would work in any situation where you have write access to a directory that's in someone's path. So, for instance, if someone is running their system with like a path with dot in it, then they are totally vulnerable to this type of thing. But anyways, I just wanted to do this little thing because I thought it was fun. So let's go ahead and fix this problem, because we don't want to have this problem. So I think the issue is that exec VE, which one is it? I think this, which one does the path use? I guess that's the important part. Okay, so the path, the shell uses exec VP. So this exec with a vector of arguments, and we wanted to do path lookup on our behalf. And then this just calls exec VPE, passes along the environment. And so here's this exec VPE. What does he do? calls execve. Okay, but the P in execvpe, that's for path resolution. So this is where it looks at the path environment variable and stuff. So how does this work? First thing we do is we try to exec just a file name. And I think that's our mistake. So I think the very first thing we do is wrong. Because if that doesn't work, and we don't get enoent, so like we don't get a file not found, then we return a failure code. But if we just get a file not found from that, then we get the path environment variable. And if we don't have it, we substitute this stuff. And then we split it by the colons. And we try execing like from the start of the path, each at a time by appending /name. All right, and then there's a little bit of sneaking around with erno because we're using C++ stuff and they clobber erno, so this code is actually kind of a mess because of that. You know, we could probably write this without C++, but whatever. But I think that this is wrong because I'm just thinking, like, what is it actually in Unix that makes it so that other systems require /? Why Unix y./ Why do you need / before executable script name? All right, hit me. Because on Unix, the current directory is not in path. Because POSIX specifies. Well, now you are speaking about language. All right, so command, search, and execution. So if the name does not contain any / characters, then the following sequence shall occur, blah, 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 blah. If the command name contains at least one /, then the shell shall execute the utility, blah, blah, blah. Okay, so if there's a separate behavior if the path name has / characters. So these are shell built-ins, I guess. Yeah, okay. So if there's a name, it's the name of the built-in, then we do the built-in, and if it's blah, 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 otherwise, where is the path lookup? Here. Command shall be searched using using the path environment variable. Okay, so that's if we don't have any slashes, but if we do have a /, then we should just try to exec it right away. We can do that. So basically, if stir or stir file name / something like that, and we can just say that we just try to run it at that point. Don't think we need the erno rollback or, or anything. Is that the fix? It's a really tidy fix. I guess that makes sense. So like if there's any / anywhere in the path, then we don't do this kind of lookup. We don't look up based on the path environment, but I shouldn't say path because I'm mixing up file name and path. If there is a / anywhere in the file name, then we ignore the path variable and just try to exec the file name verbatim. But if there's no /, then we gotta go looking for it. Okay, that makes sense. So I did not realize that that was specified by POSIX, but it makes total sense. Okay, so temp. All right, so temp. And did that give us a sneaky program? No, we don't even have a sneaky program. There's no bin sneaky. There's bin sn, which is a shortcut to the snake program, or game rather, but that's not why we came here. So cool. Let's mess around with it a bit more. So foo, try to run foo, it does not work. Okay, that's good. /foo totally works. Home and on foo also works. What if we change our path to be like dot? ls does not work. Foo works because it is now in my path. Okay, and what if we do this kind of a dumbass path? Okay, so yeah, you should definitely not be putting dots in your path. I realize that it may be convenient, but this whole thing makes me see that you really don't want to be doing that. So that's cool. Now, unfortunately, I don't think that this is particularly exploitable on this system, like automatically. There isn't really, we don't really have like these admin scripts or anything that run regularly that would go somewhere and fall into this trap. But at least I don't think so. We could look in our system server. No, we don't really have anything here. Wonder if you could, do we have a way to specify which directory these guys run in? That would be kind of an interesting hack. Oh, I would have thought that system server had a directory thingy, but maybe they don't. Path, executable path. So I was thinking, if you had like a system service that was configured to run in /temp as its like current directory when it starts, and then you would have like a sort of a sloppily configured service that looked a bit like you know, like imagine that we had the, say, lookup server. Imagine that he was like working directory /temp and wait a minute. How does, I'm just thinking like, how does it know to run the lookup server? But it's here. It's bin. Oh, I see. Executable. So it's either it's bin or it's the name of the service. Because otherwise you could imagine something that was configured like this, like lookup server. This would have potentially been a problem, right? Because then if the system server would like fork a new process and then change the directory to /temp and then exec lookup server, you would be able to trick system server into spawning a process like this. But it doesn't look like we have that sort of a situation here, so that's good. But it's better to fix this before it becomes a problem. And I don't think there's more stuff like that. Do we have any execs that do like do a relative path? I think all of these are kind of good boys, and they specify the full path. Yeah, looks like it. Anyways, so I think we can't really do too much with this one on the system, but it was still fun to make the little thing. So let's go ahead and commit the change. So LibC exec the exec family functions should not search dot by default. We should only execute the file name verbatim if it contains a slash character somewhere. Otherwise, we need to go through path expansion. We need to go through we need to look through the entries in the path environment variable. Yeah. Maybe search. Nah, that's a little too long. This fixes an issue where you could override system programs trivially override system programs by placing them in a directory you control. Easily override. Then waiting for someone in EGLS. Okay, so maybe we should make a little test for this also, just so that we have one. I need to get a bit better about testing anyway. So maybe we'll make it, this is kind of a LibC test, so how should this test look? I would like to get to a place where like the tests are these single standalone programs that do something and either like pass or fail. So how would a test for this look like? What would it be called? Exec should not search current directory CPP. And evils. This doesn't really help us, but okay, what am I trying to do? So we would have to do something like, I guess we can just do like this. Hacks. Okay, and then we will f-truncate like that, and I guess we will also make him executable. And then we will close it, and then we will try to exec it. Exec LP hacks null footer. And kernel is exec that is a fail. So turn 1, maybe, is that good? Something like that, and I mean, we can just use std out, I guess. Not exactly sure how I want this to work, but something like that. And of course, we don't have any build system that will build these automatically right now, and I'm not going to sit and mess with that at the moment. So we'll just do it this way, just for testing. All right, how did I mess that up? I forgot about the full tool. Well, that did not go well. A null dereference. Wait, what? A null dereference. In the hacks program, it actually tries to run it, but it's 0 length. Wait. Hacks is something else. Oh. I don't even remember what that is. Dang it. Alright. Some binary I had lying around. Okay, well, that could have confused me for way longer, so let's try one more time. Pass. That's good. Maybe we can do a forward and new line here. And then if we still had the bug, then let's just put the bug back momentarily here. Okay. Fail. All right, that's good. So, or let's make sure that we don't get rid of that. And I guess no matter how we exit, we should be good boys and unlink hacks. Okay. Still fails. It's good. And then with the new LibC, just have to relink. It's a nice little test, I think. This is what we should make more of these. Pass. Okay, great. Very, very good. So userland exec, we'll put that in tests, libc, there. And we'll just add this to the previous commit. Test, libc. Okay, great. Cool. So I think that's gonna be it for today's video. So we fixed a little bug and we played around with it a little bit before fixing it. And now we can no longer copy bin id to foo and expect to run foo. Nor can we run do because it does not exist. Great. So yeah, that's going to be the end of the video. I thank you for watching, and I hope that you saw something interesting. And I don't know about this particular format. It just it seemed interesting to do something like this. I hope that your things are going okay, and I will see you next time. Bye.